Hello everyone, good morning. Welcome to this lecture on representation of meaning in natural language processing and lexical semantics. So in this lecture we are going to discuss how to represent the meaning of words in natural language processing and also different types of lexical semantics we will discuss. So basically the process of translating the sentences into words and then words into the meaningful units for further processing requires semantic analysis. So once the ambiguities are resolved at the syntactic level, it is necessary to uh, analyze the meaning of words. The semantic content of natural language sentences to be transformed into a machine understandable and machine uh, uh, possible sentences and or words or phrases. So the features that you feed into the machine should be in proper form, which is suitable for the target task. So this is required because there may be complex features and ambiguous features, context dependent features, so which have to be analyzed uh, with a proper meaning. So the main purpose of this technique is to enable the machine to interpret the meaning of sentences, words or phrases and other components of text. So let's now discuss key methods of representing meaning in NLP. The first method is word embedding technique, which is to be discussed as part of the vector space models. So this method, word embedding, uh, generates a high dimensional vectors representation in a continuous vector space. So in this method, the words which are having the similar meanings or which are having the similar context are closer to each other in the vector space. For example, the word to vec and word models are popular word embedding methods that generate vector representation. So on word to vec, we use a shallow neural network to predict words context around the target word. It generates vector representation of words. For example, let us consider two words, king and queen. So these two words will have similar embeddings because if you consider royalty as a semantic feature, then these two words are sharing the common features, that is royalty. So for example, the word king for a particular vector, if you consider the word vector of king, so we can subtract the vector for man and then add the vector for woman. So this will give the vector which is closer to the vector for queen. So the global representation for words usually follows word-to-word co-occurrence matrix in a corpus. So from which it will generate a word representation, and there is a distributional semantics where we focus on words which are having similar context and which will convey similar meaning. So in this method we derive words which are uh, frequently appearing near other words, so that means that the word captures the contextual understanding of the word. For example, the word dog and cat may appear near pets, or the word animals or pets at home. So this will have similar meanings in similar context. In this method, the co-occurrence matrix is generated to track which are the words appearing near to other words in a corpus. So based on this representation of a matrix, so we use a vector-based model to train the corpus, and we represent words as vectors to encode their meanings based on context. And the next method is bag of words and term frequency inverse document frequency method. So bag of words methods does not follow word order, does not capture the word order or context. So there may be an information loss, whereas and also here the meaning is represented by counting how many times a word appears in a document or a text. So for example, the sentence the cat sat on the mat and on the mat sat the cat, these two sentences have the same representation in bag of words method. Both these sentences contain the same words, but their syntactic structure is different. Whereas in TF-IDF method, we take the weighted average of words according to how important the words are within a document and how the words are common across a collection of documents. So based on this, we try to reduce the impact of common words that does not carry much meaning. And then coming to the semantic parsing and logical representation, we transform sentences into logical representation based on predicate logic or lambda calculus. For example, the sentence John is eating an apple may be converted into a logical representation. There exists X where X is an object, and here the relation is eating. So for example, John comma X. So X is John, John is eating an apple. So we can append this another class, that is X is an apple. So where when you substitute the value for X, for example, X is a particular entity, then uh, John is eating X, where X is an apple. So we substitute apple for X. The meaning is captured as a logical relationships. The logical relationship is expressed by the word eating between the objects John and apple. So this helps the question answering system, machine translation system, or semantic analyzer to understand the meaning behind words and relationship between objects and actions to be performed. The frame semantic representation is widely used to analyze scenarios that includes various relationships and roles of objects. For example, the word buy can activate the buying frame. It includes roles like the buyer, the seller, and the goods. Let us consider one sentence: John buys an apple. So it activates the buying frame. Here, buyer is a John, seller is a shop, goods are apples, and money is $2. So this task is useful. This frame semantic representation task is useful in information extraction and semantic parsing. Here, the main aim is to understand the underlying scenario. And coming to the next topic, that is lexical semantics in NLP, we focus on the meaning of words and how the words are interpreted and interact with each other within a corpus. And here the semantics include meaning of words, relationship between words, and the lexical semantics can be captured considering the words usage also. So this task is useful in word sense disambiguation, machine translation, and information retrieval. Let us now discuss key concepts in lexical semantics. First, we have the concept called word sense disambiguation. So we know that natural language processing, the same word may take multiple meanings depending upon the context. So the word sense disambiguation task aims to eliminate and deal with these ambiguous words which are having multiple meanings for the same word based on the context. So it determines correct meaning of a word based on surrounding words. For example, the word bank may refer to a financial institution or the river bank. So, for example, the sentence "I went to the bank to deposit money" refers to the financial institution, and then the next sentence refers to river bank. We sat on the bank of the river is related to river bank. So here we use context clues to understand the word, and based on surrounding words, it determines the sense of the word. So this task is useful in supervised machine learning, unsupervised machine learning, and knowledge-based engineering and knowledge representation technique, where we use word nets for capturing the meaning. And we also deal with the synonym and antonyms. Synonyms are words that are having the same meanings, similar meanings. For example, buy and purchase may express the same thing, that is the act of buying something, acquiring something. So we have to handle this carefully. And antonyms, the words having opposite meanings to be analyzed. For example, hot and cold are antonyms, they represent opposite meaning. In NLP, we analyze these meanings of words to improve the task, like paraphrase reduction, text simplification, text generation, information retrieval. And then the next problem is polysemy problem and homonymy problem. Polysemy refers to a single word that takes multiple meanings which are related with each other. For example, the word head can refer to the head of the body, or the leader of a group, or the front of a line, beginning of the line. So the next problem is a homonymy problem. So in this problem, a single word with multiple meanings that are related need to be handled. For example, the word bat may refer to flying a mammal, or bat used in cricket match or in basketball match. So understanding these polysemy problems and dealing with this homonymy and polynomy problem is essential in machine translation and question answering. So we aim to determine the correct meaning of a word based on its context. And the next problem is hyponymy problem, in which a word whose meaning is more specific than another word need to be analyzed. And for example, the word poodle is a hyponym of a dog, because this is a specific type of dog. Poodle is a specific type of dog. And then the next problem is hypernymy. To deal with this problem, we consider a word whose meaning is more general than another word. For example, dog is a hypernym of poodle. So these relations are analyzed for generating taxonomy and constructing ontology in NLP tasks. We can also generate knowledge graph. We can enable the machine to perform semantic searching in a network. And the next technique we are going to use for analyzing lexical semantics in WordNet. WordNet is a more popular technique for analyzing lexical semantics. It's a large lexical database of English. There are several words and sentences where we can use these words to analyze. We can use this database to resolve ambiguities in a sentence. We can also capture synonyms, and hyponyme relationships can be analyzed. So we organize words into a set of synonyms called synsets, and then we link them based on semantic relationship, based on context, based on surrounding words and their meanings. So the one is synset for the word, for example, the dog includes various senses. So this can be related to domestic dog, or canine, or dog-like animals. So we use WordNet to understand the relationship between words. It helps the semantic parser and information retrieval system to capture the meanings and understand the words for the process. So that's all in this lecture. Thank you all.